Hi Eugene.
Matthew.
I had a quick question in regards to the quizzes.
Yep.
So I saw the announcement today that there's no quiz 10. Does that mean that we still have quizzes 5, 6, 7, 8, 9 for the rest of
Yeah,
the year?
there will be if I cannot complete the quizzes in time, that's a good question. Okay. I'll move the grade. I mean I'll move the weightage to your best grade.
So wait, will it go to the other quizzes, the midterms, or the exam? Do you have an idea? Or you're not sure yet?
Say it again.
Will, if we don't get to the quizzes in time, will the grade go to
I
the
just mentioned
rest
that
of the
you will go to
quizzes?
your Matthew, I just mentioned that you go to your best grade.
Okay.
Okay?
Okay.
Okay, Matthew, good question. Okay. Okay. Today we're going to continue on our example. So on Wednesday, we found one possible value of stress 1, and we realized that that value will not work at all. And this is because it is working outside the pink box of the pink rectangle. When outside the pink rectangle means the material will either fail or deform permanently. Okay, so it's not ideal. Okay, so on Wednesday we found that the value that don't work. Okay, one value that don't work. So what is the value that will work? Okay, so we're going to carry on this example. So we're going to draw at least 3 more Mohr circle. At least, no, not at least. Total of 3 more Mohr circle. Okay. Then once we are done with the example, I will start on transmission shaft, which is what mechanical engineers are bred to design. Okay, so let's go into example number 1. We're still going to continue. So just to quickly recap, we were asked to find 2 possible value of stress Y, and we have to meet the criteria. I repeat again, we have to meet the criteria where the maximum shear stress has to be 75 megapascal. So we found one possibility that don't work. Okay, so just to quickly recap, we know that stress X is equal to minus 70 megapascal. Stress Y is what we want to find, so we still don't know what they are. Stress Z is equal to 0. Shear XY is equal to shear YX, and this is equal to positive 40 megapascal. Okay, so we are again going to construct a Mohr circle to find the other values. Okay, so I'm going to construct a Mohr circle again. Okay, so again, I might not draw the whole box. Okay, so we're going to start at 160, 140, 120, 100, 80, 60, 40, 20, 0, 40, 60, 80, 100, 120, 140, 160. Now, the reason why I stop at 160 is because the material will yield at what? 150, yes or no, right? So we are going to draw the shear stress now. Okay, so this is the normal stress. So we have 20, 40, 60, 80, 100, minus 20, minus 40, minus 60, minus 80, minus 100. Okay, so shear stress, element rotate clockwise, element rotate anti-clockwise at the bottom. Okay, so we are still going to plot our stresses. Okay, so we know that our stresses are dealing with 70, the normal stress, So this is our stress X. This is where our stress Z is. And then we have our 70 for shear. So this is our 70 for the shear. And then we have another 70 for shear at the bottom. So if we look at element rotation, right? So this surface is our point X. This is our point Y. This is our point Z. Point Z is easy. Point Z is at the center. This is point Z because the normal stress and shear stress are equal to 0. Yeah. Oh, sorry, it's 40. Why do I draw 70? I do apologize. 40. 40. Yeah. And then if you look at element rotation on X, the element will rotate in an anti-clockwise rotation. And why anti-clockwise is so sloppy today? Anti-clockwise rotation. So anti-clockwise rotation over here is our point X. Okay. So now we want to find our shear center average stress number 2. Okay. So on Wednesday, right? What we did, just quickly recap, we moved the shear center towards the left. Okay, it's going towards the left over there. Today, we are going to do the shear, the average stress towards the right, not the shear center. Sorry, why am I talking about shear center? Come on, it's going towards the right. Okay, so we know, right? What we are given is the radius, right? Tau max is equal to 75 megapascal. Okay, 75. So we are going to, this is just a sketch, okay? So we are going to find what is our stress average. Okay, we are going to find our stress average number 2 for today. Okay, so it's real straightforward. We know that the stress average number 2 is equal to minus 70. Now it's going towards the right-hand side, so it's going to be a plus. Okay, so this will be equal to 75 squared minus by 40 squared. So this will give us 75 squared minus by 40 squared. Square root the whole thing is 63.44. So minus 70 plus by 63.443. So minus 70 plus by 63.443 is equal to minus 6.557. So we found our stress average. So I'm going to move it there now. Okay, so we know that it is at we know it's at 6.5. Okay, so I'm just eyeballing this 6.5 is over somewhere around here. Okay, so we found our stress average 2. So over here, this dot over here, this is our stress average number 2. Okay, so this distance from here to here, this distance that we have calculated, this is equal to 63.443. Okay, so now we know the other value for our stress Y1 or our stress Y2. Okay, so we're going to find our stress Y2 now. So stress Y2 is equal to minus 6.557 plus by 63.443. Okay, why plus 63.443? Okay, why is that? So if I draw a line vertically down here, right? So this distance that we found earlier relative to the stress average, okay, these distances are the same. It should be the same, but graphically, I think I have to shift it a bit. Okay, maybe shift it here. Okay. Yeah, it's just a bit off. One. Okay, I'm going to look at the question now. Jihan has a question. 75 squared minus 40 squared when calculating. Where do we get? Okay, so where do we get 75 squared? Okay, so we know the Eugene, today I'm like sleeping. Am I sleeping or no? Okay, 75 is the radius. Okay, so this is the radius, right? So the distance from here to here, this distance from here to here, right? Let me use a different color, or no, it gets really, really confusing. The distance from here to here, right? The distance from here to here is 75. And then the distance from here to here is 40. Okay. Okay. Jihan, is that okay? I think that's okay.
Yep, thank you.
So it's 63.443 minus 6.557 is 56. Okay, it's at 56.886 megapascal. Okay. So from here, we are going to draw Mohr circle. Okay. But before I draw Mohr circle, I'm going to sketch where is no man's land. No man's land means you cannot go there. Okay, you go there, the material will fail. So I'm going to sketch this at 150, 75. Okay. So we know that the shear cannot be more than 75. Okay. And then cannot be more than 150. So down here is minus 150. Okay. So we cannot go outside this box. So for now, this solution happens to work, but you have to plot 3D Mohr circle first. In 2D, we know it works already. So it cannot go outside. Then I'm going to draw our Mohr circle. I hope this works. I think it should. So this is our circle. Okay, there you go. Okay. So this circle belongs to our XY plane. Okay. And then we can sketch two more circles. Okay. So one circle will be about here. So hold on, 40, 80, 40. So it's a bit. Use a different color. So the next circle they're going to draw now is here. As I said, I'm eyeballing this. Okay. So this belongs before I go on, this is our in plane. Okay. Then over here, this belongs to our XZ plane, which is our out of plane. And finally, our last circle wait, 1, 2. This is our last circle. Okay, so this circle over here belongs to our YZ plane, which is out of plane.